Welcome to my YouTube channel. So in the previous lecture, that is system of linear equations ka first lecture, we have discussed some basic things and the general form of linear system of linear equation X equal to B, where A is a n by n matrix, X is n cross 1 matrix, that is system of linear equations with m equations and n unknowns, and B is also m cross 1. So now, today I will discuss some more things about system of linear equations. So let's see. First, augmented matrix and coefficient matrix. So if this is the system of linear equations where it has a general form we have discussed in the system 1, that is 1 1 x1 plus plus 1n xn equal to b1, and like this nth row will be a m1 x1 plus a mn xn equal to b bn. So this is the system of n linear equations with n unknowns. So this system is called 1. We have discussed in the previous lecture. So for this system, the coefficient matrix is A is the coefficient matrix, that is coefficients of ai for this matrix. So this is look like 1 1 1 2 1 n 2 1 2 2 2n, and the nth row will be m1 m2 mn. So this is m cross n. This is called coefficient matrix of the system Ax equal to B, where A is the system of equations with n unknowns and m linear equations. And augmented matrix is written as A B, or you can write it as this A, that is a11 dot 1n, and similarly a m1 dot a mn with this B matrix, that is this is B, where B is b1 dot bm. So if you write here, so b1 second row b2 dot mth row where mn. So this is augmented matrix. It has the same row as m, but column, this is nth column and one column is added, so this will be n plus 1. So this is the coefficient matrix for this system of linear equations 1, and the ADAS is the augmented matrix. This is the augmented matrix. So this is very important matrix. From this matrix we can say the system is consistent or inconsistent. So now we discuss what is degenerate linear equation and non-degenerate linear equation. So a linear equation is called degenerate if all coefficients of the unknown is 0, that is if it has the form 0 into x1 0 into x2 plus 0 into xn equal to b. So here all the coefficients of the unknowns in unknowns is 0, that is x1 x2 xn के लिए coefficients are all 0, but b. So solution of this degenerate linear equation totally depend on b. If b not equal to 0, so this equation has no solution. This side 0, so if b not equal to 0, then 0 equal to a non-zero quantity, you can say. So b non-zero quantity, which is not possible. So this equation will not be satisfied if b not equal to 0. So when b not equal to 0, this linear equation, that is degenerate linear equation, has no solution. And other case, when b equal to 0, then 0 equal to 0. So for every set u equal to k1 dot kn, that is x1 equal to k1 dot xn equal to kn, will be the solution of this equation. So if you name it d1, degenerate equation, so solution of d1. So if b equal to 0, then every u will be the solution of this equation. And what is non-degenerate linear equation? If there exist some coefficients for unknown which is not 0, then we call this equation is non-degenerate. So like this, here x1 and x2 has 0 coefficients, but x3 x4 has non-zero coefficients, and x6 also non-zero coefficients. So here first unknown is x3, which has non-zero coefficients 5. So here x3 is called leading unknown, so leading term. So if there is a n number of equations, and if we see first row, and from the first column, second column, first you see a non-zero element, so we call it leading term. So this will be very important for the Gauss elimination method. So when we discuss Gauss elimination method, so leading element of the matrix come into the picture. So we will discuss. We can note a proposition from this degenerate equation. So if we consider this L is a system of linear equations which contains a degenerate equation. So then how we will solve this system of linear equations which contains a degenerate equations? So suppose there is m equations, and this ith equation, that is obviously we are talking about linear equations, this ith linear equation is degenerate. So then what will happen? Degenerate equation with this constant b. Suppose this ith equation will be this. So depending on the value of b, we can solve the system of linear equations which contains a degenerate equation. So if b not equal to 0, so we can conclude that this degenerate equation will have no solutions, and this will implies that this system also have no solution. And if b equal to 0, so every solution will be the solution of this degenerate equation. So to solve this system, we delete this equation and we solve the other n minus 1 linear equation which are not degenerate equation. So whenever a degenerate equation contained in the system, and we see the constant term value, if this is 0, we simply can say this system has no solution, and if b equal to 0, then we can say we can find the solution by deleting this degenerate equation from the system. So we have discussed elementary row operations. Now we'll discuss elementary operations. So whenever we solve this type of equations, so there is m row, m equations and n unknowns. So let these equations are L1, L2, dot dot Li, Lj, and dot dot Lm, m equations. Okay, so we can replace these two equations. So we can take first and this is second, so we can replace those two equations in the system, then the solution of the system will be same, and we can replace Li by k into Li and that type of relation. So first we can interchange Li and Lj, so Li equation become Lj and Lj equation become Li, and also we can replace Li by k into Li, that is the new equation Li is replaced by k into Li. We multiply both sides of the equation by k and replace Lj by k Li and Lj between two elements. K is multiplied with one element and sum with this Lj. So we replace Lj by k into Li plus Lj. So we use R previously because we talked about elementary row operation. So we denote by R. So now we are talking about equations. So we are taking these equations. These are the elementary operations we will apply on the equations of a system to solve the system. So there is a theorem related to this operation. So let us see. So this is the theorem. Suppose a system this of linear equations is obtained from a system this of linear equations by finite sequence of elementary operations, then these two systems have the same solution. So given this system of linear equations and we obtain a new solutions this by applying elementary operations. So here is said that finite sequence of elementary operations. So we use make operations between these three, and after applying on this system of linear equations, we get this system. Then finding the solution of this system, we can say about the solution of this system, because this theorem says these two systems have the same solution. So if you are given a system of linear equations, so first you apply these row operations to reduce number of unknowns from one equations and solve the new system. And from this new system you can talk about the solution of the given system. So let us see one example to understand this theory. Suppose that in that this two equation is given, so this is a system of two linear equations, so we have to solve, that is we have to find x comma y. So what is value of x and what is value of y? So this is L1 and L2. If we eliminate x from this equation, so simply we have to multiply with 3 with this and 2 with this equation, and we have to minus, or if you add, then you have to multiply minus 3 with L1 and plus 2 into L2. So first take 3L3 minus 3L1, that is minus 6x minus minus plus 6y, and this will be minus minus plus 24. And if we take 2L2, that is 2L2, so this will be 6x plus 8y and 2 5, that is 10. And we have to add. So by adding we get minus 6x plus 6x, that is 0, and this is plus 14y, and this will be 34. So this will be 9, sorry. If we multiply 3 with this equation, we get minus 6 minus plus 9 and 24. So this will be 17. Y equal to 34, that is y equal to 34 divided by 17, that is 2. So we get y equal to 2. So by putting y equal to 2 any of these two equations, we get 3x plus 4 into y, that is 2, equal to 5. So 3x equal to 5 minus 8, that is minus 3. 3x equal to minus 3, so x equal to minus 3 by 3, that is minus 1. So we get the solution 1 1. So this is the unique solution. So this is unique case, that is this system of two linear equations has a unique solution, minus 1 comma 2. So this is the solution, x equal to minus 1, y equal to 2. So let us take a system for infinite number of solutions. If you are given this system of two linear equations, to eliminate x from this equation, simply we multiply 2 with L1 and add with L2, that is 2L1 will be 2x minus 6y equal to 8, and L2 is same, that is 2x plus 6y equal to minus 8. So if you add, so this will be 0x, this will be 0y, and this will be 0. So this is like x1 plus dot plus 0xn equal to b, where b is 0. So when b, this is a degenerate equation, so it has a solution if b not equal to 0. So when b equal to 0, there is no solution, and if b not equal to 0, every u k1 k2 dot kn will be solution for this equation. So in this case we get b equal to 0, so it has no sorry, if not equal to 0, then no solution exists, and equal to 0 means every u k1 k2 kn will be the solution. So every u k1 comma k2 will be the solution for this system. So it has infinite number of solutions. So this is non-unique case. So whenever this will be not equal to 0, so then the system will have no solutions. So we will take another example for that. You know ax plus by equal to if you know the straight line x by a, y by b equal to 1, then a straight line will be this will be x coordinate, y coordinate. So this straight line will look like, so x axis O, a comma 0 and y axis को 0 comma b पे कट करेगा. That is, this line will cut x axis at the point a comma 0 as here is a and y by b. So y axis, this line will cut y axis at 0 comma b. So the line will be this. So from this graph we can solve this question. So for this equation, let's see in other way. So it has linear equation. We put it has an infinite number of solutions. So x minus 3y equal to 4. If we take divided by 4 both sides, so it will x by 4 and this will be minus 3y by 4 equal to 1. So we have to take in this form. So x by 4, this will be plus and this will be y divided by 4 by 3 and this will be minus equal to 1. So 4 comma 0 and minus 0 comma minus 4 by 3. These two will be point. So this line will cut x-axis at this point, that is 4 comma 0, and this will be minus, that is 0 comma minus here 0 comma minus 4 by 3. So this straight line will look like this. And from this equation, if we take minus 2 common, so we get x minus 3y equal to 4. So this will be the same line. So the other equation, that is line, will be on this line. So whenever one line will be on another line, will be on the other line. So one line is on the other line. So whenever two line meets in such a way that each point will be solution. So from this we can say this has this system of two linear equations has infinite number of solutions. Whenever these two equation will be parallel, then there is no touching point, means no, this two equations will have no solutions. And if they cut only one time, that is if they cut in such a way, so this will be the only solution. So let us take another example in which no solution exists. If we take this system of two linear equations, and if we eliminate x from this two equations, so we multiply 2 into L1 and add with L2, then we get, by this operation we get 0 into x, so x will cancel and this is 6y. So 2 minus 6y plus 6y, that is 0 into y, and this will be 2, that is 8 plus 5, this will be 13. So this is degenerate equation where b not equal to 0. So we know when b not equal to 0, so no solution exists. So system of these two linear equations has no solutions. So you can check by other rule, that is here we have seen that x minus 3y equal to 4 can be written as x by 4 plus y by minus 4 by 3. So it will cut in such a way where this is 4 comma 0 and this will be 0 comma minus 4 by 3. And if you take this equation, that is minus 2x plus 6y equal to 5, and if we divide it by 5, that this will be x by minus 5 by 2 and this will be plus y 5 by 6 equal to 1. This will be parallel to this line. This line will parallel to this line. So this is minus and this is plus. So this is this point is 5 by 6 and this will be minus 0 comma minus 5 by 2. This line will these two lines will be parallel, so there is no touching point, and then we can conclude that this system of linear equation has no solutions. So in other way, you can check if these two equations are given, a1x plus b1y equal to c1 and a2x plus b2y equal to c2, then these two lines are coincide with each other if a1 by a2 equal to b1 by b2 and c1 by c2. If this happen, then two lines are coincide. For the case we have taken the system of linear equations which have infinite number of solutions, for that system we get this condition, for that these two lines become coincide. And for this case, so whenever a1 by a2 plus, equal to b1 by b2, but this not equal to c1 by c2. So for this case we get a1 by a2, b1 by b2, and c1 by c2. So this is minus half, this is minus half, but this is not equal to minus half. So these are equal, but this is not equal. So this is not equal. So these lines are not parallel to each other. So that's why this equation has no solution. So now we discuss a special case for a system of linear equations with 4 equations and 4 unknowns. That is Ax equal to b, where A is a 4 cross 4 matrix, x is a 4 cross 1 matrix, and b is also 4 cross 1 matrix, column matrix. These are column matrix. So what happened in this case? So the equation given, 4 coefficients are non-zero in the first equation, 3 coefficients are non-zero in the second equation, 2 coefficients are non-zero in the third equation, and 1 coefficient is non-zero in the fourth equation. So here first coefficient is 0, then first and second coefficient is 0, and then first, second, third coefficients are 0. So this is like, so if you find coefficient matrix for this system, we will get, so here non-zero, 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 and this is 0, non-zero, 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 0, 0, non-zero, non-zero, 0, 0, 0, and last is non-zero. So this is like triangular matrix. So this is like me, this is a upper triangular matrix. So whose each element below the diagonal is 0. So this is upper triangular matrix. So whenever the coefficient matrix for a system of linear equations will be upper triangular matrix, then this system, we say that this system is of the form triangular form. So this is a triangular form of the system of linear equations. So what is the benefit for this form? So you can see from the last equation, you can find x4. So x4 equal to 4, 8 by 2, 4. And from this third equation, by putting x4, you can find x3, value of x3, 3 plus x4, that is 7. So x3 equal to 7 by 7, 1. So x4, 4, x3, 1. And from the third equation, we can find 5x2, that is value of x2, that is equal to 1 plus x3 minus 3x4. So by putting 1 plus x3 is 1, minus 3 into x4 is 4. So this will be 2 minus 12, that is minus 10. 5x2 equal to minus 10. So x2 will be minus 10 by 5, that is minus 2. And from finally, by putting the value of x2, x3, and x4, we find x1. So this will be 3. So we get the solution x equal to 3, x1 equal to 3, x2 equal to minus 2, x3 equal to 1, x4 equal to 4. So we can simply find the solution whenever the system is of the form triangular. So the system, when the system become triangular, then we can easily find the solution. So our main goal will be making the system in triangular form. So this is the Gauss elimination method. So we have to eliminate this term from the second equation, that is x. We have to eliminate x from the second equation. We have to eliminate x means x1, and from x1 and x2 from the third equation, and x1, x2, x3 from the fourth equation. So this is called elimination method, and this is linked to Gauss elimination method. So we will discuss later in the next lecture, that is system of linear equation, lecture 3. So for today, that's it. If you like it, please subscribe my channel and share with your friends. So it will be very beneficial for the students of Trigonometry Bhagalpur first year, whose course code is MA101. So thank you very much. Follow this lecture series. It will be very beneficial.